Yeah.
A Dell Inspiron 5000.
Huh. You should well, you can go under the microphone stuff and test it out too.
Yeah, that's what my buddy was doing beforehand, but
Oh,
he couldn't figure it out.
I know
So
we
we were
were
like,
talking and I was like, "Whoa, it's a man. Where'd she go?"
well, yeah, I like blocked it out so there wouldn't be any video of him working on it, and then he like turned it back on, and I'm like, okay, fine, if that helps.
I know we were talking and I was like, "Whoa, it's a man. Where'd she go?"
Well, yeah, I like blocked it out so there wouldn't be any video of him working on it, and then he like turned it back on, and I'm like, okay, fine, if that
It's
helps.
okay. It's weird. It did that last week too.
Oh no.
What is happening? Okay, hang on. Ah. It says I'm in 2 different calls right now. I don't know what to do.
I think it's because you're on a call in your computer. So like you can leave your computer on.
It says I'm in 2 different calls right now.
Oh my
I
gosh.
don't know what to do. Everything's coming from my phone. I don't know what to do. Oh my goodness. Okay. Let me see. Okay. Okay, so we're still live? Yes?
Yeah.
Okay. Okay. What's doing that? Oh my gosh.
I just realized I don't have any of the assignments pulled up.
Yeah, I'm in the door.
Okay, so we're still live?
Oh no.
Yes?
Still doing it.
Yeah. Okay.
Here we
Do
go. I just realized I don't have any of the assignments pulled up.
Sorry, my face is weird. Uh, okay. Are we good? Hello?
I'm here.
Okay.
I'm just pulling up the.
Oh goodness. I'm so sorry about all these problems. I don't know what's happening.
It's okay. All right, let's start with lesson 6, group meeting. Did you guys catch that he said something about you have to put a comment on both discussion boards in order to get credit?
Oh, really?
Yeah. Under his notes from instructor, it said that. So
Okay.
you just have to comment that you were there, I think, but you have to put it on both lessons, or else you won't get credit for it.
Okay. That's good to know.
Are you guys ready to start group meeting 6?
Yep, I'm good.
So
Can you guys hear the
you
echoing,
just have to
or is
comment
that
that you were
just
there, I
me?
think, but you have to put it on both lessons, or else you won't get credit for it.
Okay. I'm here.
Hi, Claudia. Are you guys ready to start group meeting 6?
Yep, I'm good.
So
Can you guys hear the
you just have to
echoing, or is
comment
that
that you were
just
there, I
me?
think, but you have to put it on both lessons, or else you won't get credit for it.
Sorry, I'm here.
Hi, Claudia. Are you guys ready to start group meeting 6?
So one.
So
Can you guys hear the
um. Are we still there?
Yeah.
Okay. What I just noticed a couple minutes ago was I accidentally had like 2 calls going on at the same time. I don't know how it happened, so I had to exit out of one. So I don't know if that's happening to one of you guys.
No, but that happened to me last week. I know what you mean.
Because I think I
Okay.
original invitation, and then there was like another one I clicked as well, and so it opened both up or something.
Yeah. Okay. I think it sounds good now.
Okay. No more phantom ghosts. Okay. Oh man.
All right. Let's get going. Number
Yeah.
3. So, number 3. I don't think this is really worded right. When using the when examples of n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? So,
She's gone.
since it's a low sample, since the sample is less than 30, it'll stay right skewed.
Yeah.
What if I just did this whole one and then you, like, one of you do the next one? Then we don't have to worry about taking turns so often.
Okay. Yeah.
Did we lose Jessica?
I don't know. Oh my goodness. Last week went so smoothly. I don't know what's happening.
It's like 9:35 and we haven't even started.
Are you in Rexburg?
Iona. It's just outside Idaho Falls, just south of Rexburg.
Oh, yeah. Okay.
Are you in Rexburg?
Uh-huh.
Okay. So are you married or are you up there?
I am single. I'm still in approved housing.
Oh, okay.
Yeah.
Where are you from?
I'm from Illinois.
Oh, wow.
Yeah.
You're a long ways from.
Yeah. What about you?
I'm from here. Cool, huh? Idaho Falls, yeah.
Nice.
I lived up there on campus for a year, like 18 years ago.
Nice.
Yeah, I'm old.
You're not that old. Where is Jessica?
Shoot. Oh, there we go.
Oh, there you are. Welcome back.
I had 3 going, so I
You
could understand that.
There we go.
I was like, what the heck? And then I somehow heard you say you had more than one. And I had it like pulled up previously, and it must have just started automatically, like without me going into it. And so I had like one saved, and then anyways. Okay, so I'm here now.
So we're still on live, right?
Yes. It's all proof
Okay.
that we're going crazy.
Okay.
Okay, hold on. Let me read
So what?
quiz. I didn't get anything because literally all I heard was people talking, like echoes over and over and over.
Okay. What do you think about we each taking the whole assignment? I think that'll be faster.
What?
Like if I read all of them on this one, and then we can kind of go through faster.
That's fine.
Okay. So we start with 3.
Okay.
The sample's 5. What is the shape of the distribution of means to histogram when the parent population is right skewed? I mean, you can all say the answers, but I'll just read all the questions. So since the sample is so low, less than 30 will stay right skewed.
Yeah. Wait. Did I miss number 3?
That is number 3.
Yeah.
So then number 4, when taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed? And so the difference is that it has a higher sample, so it's normal.
Yep.
5, when using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed? And you don't even have to use the applet. Yeah, it's normal because the parent population is normal. 6, when taking samples of when n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? And it's also normal because the parent one is.
Yep.
Okay. When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. That one is checked because it's normally distributed. Data are drawn from a population that is normally distributed and the sample size is large. And that is checked because it's normal. Data are drawn from a population that is right skewed and the sample size is small. Is not checked because it's a small sample size. And the last one is checked because it's right skewed with a large sample size.
So 1, 2, and 4?
Yeah.
Yeah.
That's what I thought. Okay. I couldn't tell if you said not on the
one. 8. Which of the following gives the best explanation of the central limit theorem? So it's the third one, or C, I guess.
Yeah.
The sample size is large, the sample mean will be close to the population mean. And then number 9, so we use the information up top. What is the mean of the distribution of sample means? And the mean of sample means is always equal to the parent mean, or the population mean. So it's 10. What is the standard deviation of the distribution of sample means? So number 10.
Okay, hold on.
So you take 6, which is a standard deviation, divide by the square root of 36, because that's the
1.
population. And it is 1, yes. 11,
But
regardless of the, oh, sorry, what?
Do you have to put 0.000 if it's asking for 3 decimal places?
No, he didn't. Just
Okay.
1. Regardless of the distribution of the population, if the sample size is large, what would be the shape distribution of the distribution of the sample mean?
Normal?
Yeah. It's normal because it's a large sample size. What theorem would justify your response to question 11? And it's the central limit theorem. I don't know if I would have guessed that last one right, but that's what it is. Still need to go back and figure out exactly the difference between those two.
Christopher, stop.
Oh, I
Oh,
missed 8.
8.
Shoot.
Oh, it's the last one.
Ah, it is, yes. Sorry.
Oh, because the sample means the same as the population. So that one was wrong, yeah.
What did you guys put for 10?
Approximately normal. 10?
Yeah.
I put 1.
You didn't have to put decimal thingies?
No.
No. Did you put 1.000 and it marked it wrong?
Yeah.
I would just email him on that because he'll change it.
We won't count that.
Sorry about 8. I had it written down right. I just didn't read the rest.
Sorry, I don't know where to put my phone. Okay.
Christopher, no. Okay. Now.
Lesson 6 homework.
Do we want to go through homework or are we just doing the group meeting?
Oh, right. Right.
I mean, if you guys want to do the homework. I've already done it, so it saves time if we don't.
Yeah, let's just go to 7.
Okay.
And then Laurel, if you want to go through it. I don't mind.
I'm fine. Yeah.
Group 7.
Okay, so 7 group meeting.
Oopsie. Yeah. Okay, go ahead.
Sorry, mine's taking forever to load. There we go.
This one's a big quiz.
Oh yeah, this is a little bit bigger. Do you want me to read all these then?
Sure.
Was that yes? Okay,
Go for it. Sure.
Okay. Number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer. Okay.
Oh, what was that link that you guys posted last time? I didn't. Is that the same thing?
Yeah, it's the better one here. I've got it.
I forgot to save it. I was trying to like find it, but I didn't know how.
He put it on the week summary, whatever that first page is. It's
Okay.
Yeah.
Oh yeah.
like where the Adobe Connects are. It's like right above that. It's hard to find, but
Okay.
it's there. Okay, so to the
Right.
okay, so we're looking outside of those. So I have 0.175 for that.
0.175.
Yeah, is that what you got?
Yeah. It threw me off that you would do mean 0 and standard deviation 1 though. I guess that's the basic for a normal, standard normal curve.
Yeah.
I just have to remember that.
Number 4, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that was observed in the sample. Okay.
I know. I'm like rereading it.
That was a lot of words. Okay.
He even got this one wrong the first time he did it.
Brother Doria?
Uh-huh. I had to go back and figure it out again. So, so since it's a sample size, you have to refigure the standard deviation. So the mean stays with 5. For the standard
135?
deviation. No, 185.
Oh, right.
And the standard deviation will be 26.7 divided by the square root of 48, which is 3.8538. And then you can do, oh, and to get the outside on both sides, this is tricky too. So if, just, how do we do that? Okay, so since the mean weight is 185, but the sample mean is 177.6, it's the outside of 177.6. And then we had to take 185 minus 177.6, which equals 7.4. And then we had to take that 7.4 on both sides of the mean. So it's outside the 177.6 and 192.4. Does that make sense?
I'm so lost right now.
I know. Okay. So if you look at the picture, 185 is the mean down the middle, and the sample mean was 177.6.
Right.
But it wants to know, the question was worded, it wants to know as extreme or more extreme. And then down at the bottom it says they're interested in the values that are lower and like the far away values, both high and low. So I don't know if you can see in the picture how it has it shaded on both ends of the chart.
What?
After you enter outside.
Are you on the David M. Lane site?
Yeah, yeah.
So which one are we doing?
What'd
The
you
area
put?
from the value.
Okay, right.
And you click outside 177.6 and 192.4. And so both of those are 7.4 away from the mean. So you had to figure out how far away between the mean and the sample mean, and then do that amount on both sides of the mean.
So is the
So-
answer that 0.5 or 0.05?
I'm so lost right now.
That's not the answer yet. Hang on.
I'm gonna have to go back and watch the video again.
You're gonna, yeah.
Yeah, I didn't watch the whole thing again, and I didn't see that part.
I
Okay,
watched.
well, if you, on the second video, I have about where it's marked. On the second video, if you start about 5 or 6 minutes into it. But he got it wrong. So at the very end of the video, you have to watch as he goes back and fixes it. Because I'm not even getting the right answer now.
Okay, sorry. So on the applet, we're doing area from a value, correct?
Yes.
Okay. And then you put in 185 is the mean,
Mm-hmm.
and then standard deviation 3.85.
853.
Okay. And then you click outside of 177.6.
No.
And what was the other number?
192.4, but it's not giving the same answer as he got. So somewhere I went wrong.
His first or second answer?
Oh, 5.
Neither. His first answer was 0.773. The second answer was 0.046.
Well, I'll have to go back and watch the video.
Well, it's 0.046 if you want to get it right for now, but
046.
0.046.
Okay.
Weird.
Because he went back and made sure the answer was correct. But I think it's something wrong with the outside two numbers. Maybe try and refigure those.
Okay. Well, I'll look again.
Yeah, I don't know. Sorry, I lost my place. Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Distribution of the individual's observations, distribution of the sample means, or this cannot be determined. Isn't it the sample means? Doesn't it get smaller?
Yeah. Because it's always divided by the square root of a number, so it's always going to be smaller.
Yeah. Okay.
Sorry.
Okay. Which of the following results implies that the spread in X-bar decreases as the sample size increases? Normal distribution, the rule, central limit, or law of large numbers?
Which of this?
That's the law of large numbers, isn't it?
Yeah.
Yeah.
Alright, scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. And Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So,
I don't know. Christopher. Go get your tablet. I can't move. It's in the drawer. Yeah.
so is this just like 160 minus 150.8 divided by 8.8?
Yeah.
Okay. I don't have my calculator up. So 1.045?
Yeah.
Okay. Alright, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Okay, so we plug that.
160. Bye-bye.
.148.
Wait, what'd you put in the calculator?
So the mean is 150.8, standard deviation is 8.8, and then above 160.
Oh, back to that little thingy. Okay, hold on.
You guys got .148.
And I don't know if you guys know this, but if you have a z-score, you can do mean is 0, standard deviation is 1, and then click whichever one you want it to be and put the z-score in there, and it gives you the same answer.
Oh, okay.
I didn't know that. I'm the athlete.
Hold on, Christopher. Mommy has to do homework. So it was 1.41. No, 0.148. Stop.
0.188, yeah.
Hold on, Chris.
All right. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What's the z-score corresponding to the sample mean of these students' scores? Okay.
So
you have to figure out the new,
you just find the new mean?
not the new mean, but the new standard deviation. So it's 160 minus 150.8. So you keep the mean divided by 3.935.
160 minus 150.8. Then
She's done.
Oh no.
I disappeared. I'm back. Sorry. My son pressed the power button on my computer. Okay, so I left at minus 150.8.
And then divide by the new z-score, the new standard deviation.
What? Okay, well, I'm too busy right now. I can't answer it. Here. Divided by
3.935.
3.935. 2.337.
2.338.
Oh, right. Rounding. Okay.
Sorry.
What?
Sorry, what was number 9?
2.338.
Okay, sorry. I normally use my phone as my calculator, but it's being used as video, so I'm doing everything by hand. Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
What is the probability that 5 students will have a mean score that is greater than? This is the Z table, right?
So we're looking for greater than 2.338.
So would that be like above? Or is that something else? Am I lost?
I got 0.0097.
Yeah, that's right.
Okay.
On what? The Z table thing?
On the applet.
What'd you do? I didn't get that.
Yes, you want to look up. So if you put the applet back to mean of 0 and standard deviation of 1,
Oh.
and you're looking above a z-score of 2.338.
That might be a problem. 0097. Okay, got it. It should just reset on its own every time.
Yeah.
I actually have like both of the applets open, so that way I don't have to reset the other one. Because the old one, the really basic one, it only does mean 0 and standard deviation of 1.
Yeah.
I mean, if that helps, but
Okay.
okay. Suppose the mean GPA of BYU Idaho students is 3.5, standard deviation of 0.7. It's well known that this distribution is less skewed. A random sample of 81 students will be drawn using this information. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected? Wouldn't it be approximately normal because it's a large sample?
What is the shape? I would think so. Yeah.
It is. Yeah.
Oh, where'd Stacy go? Stacy Lee? Oh, there you are. Okay. What is the mean of the distribution of the sample means, sampling distribution for all possible samples of size 81 that could be drawn from the parent population?
Shh. Okay, I'll fix it in a minute, buddy.
Wait, isn't the mean's the same, right? So
Yeah.
3.5.
yeah. Okay.
Yep.
Standard deviation 0.7.
Well, do we have to calculate new standard deviation?
0.78. Yeah, it's fine. So you have 0.7 is square root of.
I didn't get that. You cut out.
Oh, sorry. And so you the standard deviation, which is 0.7, divided by the square root of 81, which is 9. So
Okay.
0.078.
0.078. Okay.
All right, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Hold on, buddy. Go get a diaper and wipes. Go get it. Hold on, Chris. 1 second. Oh. No. Come here. Okay, there you go. Okay, sorry.
You're
Okay.
What is the standard deviation of sample size? 81 who are selected. So, how do you do number 13? No. Chris, wait.
The last, wow.
Yeah.
13, it wants to know the standard deviation of the sample size. And so you take the standard deviation, which was 0.7, divide by the square root of 81, which is the number of students.
Didn't you do that for number 12?
That was 13.
Yeah, for 13.
Okay, the answer for
So we're on
number 12
14.
is 0.078.
No, that's 13. 12 was just the sample mean equals the population sample mean, so it was 3.5.
Huh, okay. Oh, got it. Okay, 14. Okay.
So 14 you want to do in the applet.
Okay.
The mean, it pretty much just takes the information from the last two questions. So the mean was 3.5, the standard deviation was 0.078, and they want to know how many are below 3.3.
0.0052 or 5, just end at 5?
Yeah.
Yeah.
0.05.
Okay.
All right, what is the
And so
probability?
Oh.
Sorry. What is the probability that the mean GPA for anyone randomly selected BYU Idaho students will be greater than 3.3? So just the opposite.
Same problem, just above 3.3.
Above.
0.995?
Yep.
Yeah, that's what I see.
Oh, well, I guess we could have done that with simple math. Okay. All right. Everything looks good?
I think
Yeah.
so. Alrighty.
Sweet. Good job, guys. we're done.
Okay.
Alrighty, we are good. Next week,
Okay.
I will start the first quiz. And, I think that's all.
So next week we have the first exam.
Whoa! Can we do the exam together?
I don't think so. I don't know. I doubt it.
No, yeah, I don't. I can't see it yet. Probably not.
No, I don't think so.
I
So,
thought you meant it was like a group exam, but I just
No.
looked and it's not. It's separate.
but it looks like the first half of the week is just preparing for that,
Yeah.
and then we have a new lesson.
Says 8 and lesson 9, we still have a group meeting.
Do we still want to wait till Thursday?
I'm fine with.
Or do you want to try and?
Meetings not due till Saturday, right?
Yeah. Okay.
I'm fine with that, unless you want to switch it. When are you leaving?
I'm not leaving for a few weeks.
Okay.
I don't know when. No, let's just keep Thursday then.
Okay. And I'm gonna find out if there's a way, like if we're not available to meet at a meeting, if there's a way we can like make up the points. Because previously, like I would, in my other math classes, we would just fill out the answers and like submit it to someone.
Oh.
Thank you, Christopher. But I guess that would mean I'd have to do the group quiz by myself. I don't know. I'll ask. I'll figure it out.
Okay.
Okay, I'm going to stop this broadcast.